investment annuity. So our discussion today, we're going to check about investment or annuity. But before then, last time we did about the loan and loan amortization, and we discussed the functions that we use when computing the loan, the interest, the principal. We separated the principal and the interest from the amount paid every period. So our functions today, we're going to check on now functions that we use specifically in investment. So we're going to answer one question from the past paper that is covering about the loan before we proceed to our discussion today. If you have your past paper, you will check on one of the questions. I'll show you, I'll display how these questions are brought in exam. And from there, you see how you're supposed to. So once you log into the examination portal, then section 2 of the questions, you're supposed to download the worksheet. So the worksheet that you download will resemble exactly the worksheet I have here. Hope you can see that worksheet. That is, when you log into the examination portal, you are given an option to download the worksheet. That is for section 2. So this worksheet, you have the questions. We have 3 questions, question 21, question 22, and question 23. So above here, you are given an option where you type in your registration number, because that is a CASNEP number. So you type there. The question is framed here in the same worksheet. The data is given here. Then we have your working. The questions are asked here. These are additional information. We have the requirements. That is what you're supposed to do. Then once you read everything, then you can tackle down your question down here. That is what you'll get. Once you download the worksheet, that is what you get. So the question that we are going to tackle is question 3. The question 3, we had 2 sections of this question. So the first one, you are supposed to compute an investment. That is what you are going to start today. You are given an investment that you are a financial manager, consultant. You are supposed to, a potential client requests you to analyze an investment. Here you are given the cost of investment, you are given the investment payouts, and a number of things. That is what you are going to discuss today. So question A is not what you are solving, because we have not discussed that one yet. We are solving question C, because this is what we have been discussing. So we are told here that assume that an investor take an investment loan of 150 million. The loan is for 48 months at an annual interest of 15%, which the bank translates to monthly of 15 divided by 12. That is 1.25%. The payments are made at the end of each of the next 48 months. That was the question. And now here you are told that assume, okay, there is something missing here. Question Roman 1 is missing. The question Roman 1 was actually, you are supposed to calculate the monthly payment for the loan. So you can check that question. from at past paper. So just a minute, let me check. Where is past paper? So the first question read here, calculate the monthly payment for the loan. Calculate the monthly payment for the loan. That was the first question. Calculate the monthly payment for the loan. And this is the worksheet you are given. Then how do you solve this question in your worksheet? Down here, you are supposed to do your working from here down. And you see, CASNEP will not formulate the data for you. You have to formulate this data so that to solve that problem and give out the solution. So what do you mean by formulating? First, you have to indicate the amount borrowed. So here you type loan. That is the amount borrowed in a specific cell. Then you have to indicate the duration. The duration you are told is in months. So you type, let's type properly. So that is the loan. We have duration. Duration is in months. I told 48 months. Then you have to set up the rate. You are given that the rate here was 15%. So you type here the rate. And finally, you are supposed to get the monthly payment. The monthly payment. That is what you are computing. So, alignment of your work, you have to do your alignment properly. So this is solution 2. You have to indicate that you are solving question 3(2), question 3b. You have to indicate that these are the solutions. How do you do that? And even merge the cells. Then here you type solutions. Don't mix your work. So you have to set up solutions here, and you want to tackle out these solutions here together. We're going to do Roman 1 A, because that is what we have already discussed yet so far. So the loan borrowed was 150 million. That was the amount borrowed. The duration was 48 months. 48 months. The rate was 15%. And you're supposed to compute the monthly payment for the loan. Someone is saying this here, the question. Okay. That question paper I've shared long time ago. Okay, I'll share the worksheet. I'll share the worksheet, not the class paper. Just share the worksheet so that you can download the worksheet and you can work together. So in our previous lessons, we discussed on how you can create your worksheet, the effective way of formulating your worksheet. And we have been doing this one for a long time now. So that means now everyone is possible to actually formulate the data and work with the data. So if you have, maybe you have not yet experienced using of Excel, especially to formulate your work, you need to do a lot of practice, especially on the exercises involving working with Excel. Just a minute. Share this. Taking too long to load. Pass. So I'm sharing the worksheet. Just a minute. The worksheet here. The worksheet. This worksheet. So we've got the worksheet. I've shared there. I'm also sharing the worksheet on WhatsApp. So you can get it, you download from WhatsApp. So I've shared that worksheet. Now download the worksheet and move to the third tab. The third tab. The third tab. You have the first tab is here. Question 1, question 2, and question 3. We move to the third worksheet. We are solving the question 3, Roman. That is B. Question 3B. We have already formulated our data. So solutions here will indicate that we are setting up our solutions. And here you can type solution for which question, then you indicate. Remember, you have to arrange your work properly. This is question 23 B. Of course, you have solved A before you do B. So now we are solving B. That's fine. Then you can arrange your work properly, set up the borders for your works. Always better to have the borders. And you're supposed to compute the monthly payment as per our question, that given this information above here, calculate the monthly payment. Please confirm that you have got the worksheet, and please confirm that you have already opened your worksheet and you have formulated that data. That is how we have just done this work here. No one has downloaded the data? So now we want to perform this working together, and remember that this question can be done even in manual way. Remember, you can do this one manually. using the manual formula. That is the formula you discussed there in your previous sessions. But now here, CASNEP has requested that you should use Excel. So that means you should use the power of Excel to get this function, to get this monthly payment, which we learned that if you want to calculate the monthly payment, then you have to use the PMT to calculate the payment of the loan based on the constant payment and a constant interest rate. So you select PMT, then you click OK. So we are given the rate. The rate here is 15%, but you have to divide by 12 so that you get the monthly rate. Then again, you have to consider the number of that is the number of periods, and we are given 48 months. We are not given years, we are only given months. So there you don't have to multiply by 12. Then the present value, that is the amount of the loan, the amount borrowed, which is 150 million. And we are told in the same question that the payment are to be paid at the end of each of the next 48 months. That means you have to indicate the type here. And the type, we are told that when indicating the type, this is a logical value. The payment at the beginning of the month, we use 1. The payment at the end of the period, we use 0. So that means in our case, we are going to type there 0 because the payment was made at the end of the month. Once you finish, you click OK, it will generate the monthly payment for that loan. That is the amount of money you're supposed to pay every month. So that is how you have to solve that question. I hope that one is very clear. And the next question, though we have not covered that, but it's something we can actually check, that assume that you have the following options to negotiate with the bank. The first option is actually the scenario that we are running currently here, because we are told that the annual interest is 15% and the term is 48 months. That is the case you have here. So we are supposed to compare between the next two options. That is, in case the same amount of loan was to be paid with 18% and 60 months, then the other one to be paid 13% and 36 months. Then, after evaluating this, you are supposed to use the power of Excel. I know some people will be tempted to do like this. That is, you copy, use the first one, you paste there. You copy this one, you paste down here. Then you change the values. That is, here you say the first option was 60 months. So you type there 18 and the number of months 60. You'll be forced to do that. But when you do this, you are not actually solving the equation as per expected by CASLET, because CASLET, they have actually indicated that you are supposed to use a two-way data table. And data table is actually a function in Excel, which we'll come to discuss under the what-if analysis, the use of data table. We have two types of data tables, one-way data table and two-way data table. But whichever you use the format, you use the data table, it will finally give you the same solution. It will give you the same solution. That is, after running this, that is 36 months, so you type there 36. It will give you the same solutions. But now the question is here, determine which option would be most favorable to the investor. Which option should be most favorable for the investor? Now here you are supposed to explain. After you are working, you are supposed to explain which option will be most favorable for the investor. There is something that we saw previously, that The longer the duration, the higher the interest. So meaning that where the duration is long, then the interest will be very high. That means that will be not favorable for an investor. Then you check for this loan where the duration is the lowest, and that is 36 months. Here you pay the least interest. That means for this particular option, it will be most favorable for an investor. So where do you type that that argument? You have to type down here. You can merge cells, and you say that according to this, you have selected option 2. Reason being that here, the investor will have to pay the least interest. So you have to explain that. So, but we said you have to use the data table, not this one. So it will produce the same output, but you are supposed to compute that one using the data table. We are going to discuss data tables later. Up to that far, that is what you have discussed so far. Someone has said we repeat the PMT is something we have done so many times. We say that to use the PMT, you insert the function. Where do you click insert function? The command above here, fx. Then if PMT is not available, you have to look for it. Then you click go. You select the function PMT, you specify the information given. That is the rate you are supposed to pay. This is annual rate. It is annual. We were told that here the loan is for 48 months at an annual interest rate of 15%. So that's why we are dividing that rate by 12 to make it months. Then the number of periods, that is 48 months. We are given this one in months, so you don't have to multiply by 12. Then the present value is the amount borrowed. And we said that the loan is supposed to be paid at the end of the month. So we indicate here using a 0. Then you click OK, and you get that as a monthly payment. So I think that one is fine, and you have already done that. So our discussion today, we are going to discuss about investment. We have been discussing about loans for like 3 lessons now. And we want to shift our gears to our next discussion. That is the part of our syllabus that we are covering right now is that part we are referring to as financial management. If you check from this syllabus, let me go back there a bit, just a little bit. Just allow me to share that syllabus again. So whatever we are covering right now is the application of business data analytics. That is the core application of business data analytics. The application. And what we are doing right now is this part we are calling the what is it? Financial management. That is what we are covering so far. We did the loan amortization, and we are able even to compute the loan amortization schedule. So our next discussion, we are checking on the project evaluation. And we are going to check on this, how to evaluate projects. That is what you did in capital budgeting. You remember about capital budgeting. So in the same case, we are going to handle both the time value of money analysis and different types of cash flow. At the same time, we are going to evaluate the project using the net present value and the internal rate of return. So, but all these are a function actually that we learn through something we call, that is what we refer to as the investment function. That is under financial functions, you'll get that investment and annuity. What do we specifically mean by investment? some of the functions that we use under the investment. This is now different from the loan, because the loan, you are taking the loan, then you are given the rate, and the amount you are supposed to pay for the loan. But now here, you are given, or you deposit a specific amount into a saving account. You are given an annual interest rate, and you are told how much will your investment be worth after a given duration of time. That is what investment is all about. So we will start with the simplest function that we use when computing the investment. That is, the first function is future value. Future value. So if you have your book, you can say something about future value. What is this future value? Then you can say that future value, that function, future value, hope you have written. Just have your book and a pen. I see some people are struggling to get the pen right now. You should have the book all the time. So the future value returns the future value of an investment based on a periodic constant payment, and a constant interest rate, That is what this function do. So in a very simple way, we are going to check this function here and how you can use this function to solve or to compute some values. So I'm going to open a worksheet. This worksheet, we have to share it. Let me see whether I have it here. Then I'll open that, what do you call this? Investment and annuity. Good. This is a piece of data. Remember that we said you not be able to be typing this data during the class sessions. That way we are sharing those files so that you can download them and you work with them. So right now, I'm sharing that file. The file is written investment annuity. It has only the one worksheet. So you get it. Just a minute. So the file was already worked on. So probably just a minute. This file. Let me get the file first. Just a minute. And it resembles what you have seen, you are actually seeing on there on the screen. If you are very fast to type now, could have already finished. But I know there are some people who are very slow. So just type that data as I share that file. So I have sent that file in the system there. So you just download it. And again, I'll share it in WhatsApp. So you can download the file. And once you download the file, the first worksheet is where this file is. So just put there on that new worksheet. Sheet 1, this is our data. So from this data, you'll see something that the annual interest rate is 8%. The duration here is 10 years. And the amount, okay, there's something missing. The amount is, the amount to be paid is $100. You can type that. That is the amount that will be paid. You're supposed to look for, the future value. Just a minute. The future value. Supposed to look for the future value. So in a very simple discussion, you can say, if you invested $100 for a period of 10 years, that is every year you give out $100. If you multiply $100 by 10, then it means that in future, if the interest was not bestowed on this investment, you have already invested $1,000. But now I want to see, with that rate that is given, how much will you get as the future value? So the reason why we have indicated this one as negative, because it's a payout. This is the amount that you are going to pay every year. So you are going to insert the function FV, that is future value. So you can either type it direct or you can click insert function above here. You look for the function. If it is not there, you search for the function. And the function will appear down here. You can select it. The function returns the future value of an investment based on a periodic constant payment and a constant interest rate. Then you select the rate. The rate you are given, the rate here is 8%. And since this is annual rate, and this is years, and this is yearly payment, there's nowhere you are going to multiply or divide by 12. So the total number of payments is 10 years, and the payment right now, the yearly payment is $100. So that means by the end of this payment, by the end of this investment, you have already invested these amounts. So that is the first function we use under this investment. That is, the argument is like this, that in 10 years' time, you paid 10 multiplied by $100, that will give you $1,000. That is what you're supposed to actually to have invested. But since you have the interest, the positive value, the interest, you will receive this amount, positive. That is the amount you receive after that investment after 10 years. So when you realize that the higher the interest, then the faster your money grows. If you are given a higher interest, then your amount or your money you have grown much greater than this. So meaning that if we increase the rate, for example, we say that our rate was 12%, then at the end of our investment will be higher. So that means the higher the interest, then the higher the future value. That is how you compute the future value. The first function that you compute here. So the other function is when you are given to compute the present value. The present value, that is another function we use. And the present value, that in the last two arguments, optional, and the present value was 0, it's omitted. That is in this function here, future value, we never presented the present value because it was not given. And the type, again, we say here that the value representing the time of payment, either at the beginning or at the end. This payment was paid at the end of every month. So what will happen if the loan was to be paid at the beginning of the month? That is not the loan. If the investment was made at the beginning of the month, that is, we type 1 here. And when you type 1, click OK, you will realize that the amount will change. I don't know whether you have noted that if the money is paid at the end of the month, at the end of the year, that is, this is what our investment will be worth after 10 years. But if that amount is paid at the beginning of every year, then the amount will go a little bit higher. So I don't know whether there is anyone who can explain that. Anyone who can explain that? Say something. There is a difference of investing the amount at the beginning of the year and at the end of the year. There's something we come to discuss later called the time value of money. Value of money. Time value of money. Someone is saying that the received interest also generate interest. I don't think that one is really true. But what will make this one happen is that when you are paying this amount at the beginning of the year, then that investment is actually more worth than you are paid at the end of the year. So I will come to discuss later about time value of money and how it affects an investment. So to compute the present value, then this is another function that we use. You can write it somewhere. And the present value does what? The present value returns the present value of an investment. To return the present value of an investment. I believe that you already know the formula of getting the present value. And sometimes you'll be forced to use the formula too. So that is the present value equals to, is it 1? Is it 1 minus what? You know the formula. You can type it there. See those people who remember these formulas. Someone is asking why I put 2 commas. Why? In the future value. The commas just generated themselves. Why did he put these 2 commas? Yes, because of this simple reason that we never presented the present value. So Excel automatically set 2 commas because we never presented the present value. That's why we have the 2 commas. So the consolidated notes, you are going to get them very soon. So I want to consolidate them according to the syllabus. So you'll get them together. Don't worry about them. First, master this. This is more important. Because when you get the notes, you just now read from the notes. It will be very easy. So you'll get the present value by inserting that function here. So you look for the function present value. You search the function present value. Then you select OK. Then from there, you select the rate. We are given the rate, annual rate, here as 6%, annual. And since this is annual rate and you are working with the monthly payment, so you have to divide this one by 12, make it month, that is monthly rate. Then the duration, here we are given 20 years. Again, you have to multiply by 12 so that we get the duration in months. Then finally, you pick the monthly payment, the amount given here. And once you do this, you get the present value of this amount. So those 2 functions are the first function that you need to understand that we use when you are computing annuity and investment. When you are looking for the future value, then you use the function future value. When you are looking for the present value, and remember that minus here does not indicate an error. The minus here means payment. It means payment. It does not mean that is an error. So then our next discussion, after the present value you have seen, we have computed the present value, payment here, we have inserted the function, and the final result you get is this one here. So that you need one-time payment of this amount to pay this annuity. That is what simply it means. Because if you are to pay this, you will receive 2240 times this amount, which will be this amount here, that is this amount here, in the future. In the future, if you are to compute the future value. So this is another example that money grows over time. Money grows over time. Money grows over time. So I think that one is clear about this future value, and we have what? And we have the present value. So there is something that we'll come to discuss probably in our next lesson about the compound interest. So this one you not to tackle it today. I want us to have a good consolidated example that we can use so that we can compute that compound interest. You have the compound interest, and the other thing, you can note this one, the compound interest somewhere. We'll come to discuss in our next lesson, and something else you call the compound annual growth rate, the compound annual growth rate. So we discuss this one on Saturday. So that is with some good examples. So that is the first function that we use to compute this. So our next discussion today, we're going now to proceed to the next functions that you're going to use when computing the investment. That is, we're going to check on the net present value. We have computed the present value. Now our next discussion, we're going to check on the net present value. And before we do this, where do we use these functions, the net present value? And this is something we call capital budgeting. And capital budgeting is something you did learn in advanced financial management. And we were told that capital budgeting is actually a process, refers to planning process, which is used for decision making for long-term investments. That is, that whether the project is fruitful for the business and will provide required returns in future or not, it is important because capital expenditure requires a huge amount of funds. Before doing such expenditure in capital, the company needs to ensure that the spending will bring profit to the business. That is what capital budgeting is all about. So that is capital budgeting is decision-making process where a company plans and determines any long-term capex, which returns in terms, whose returns in terms of cash flow are expected to be received beyond a year. That is 1 year. So maybe we are going to check this. And the function that will help us to do this, one of the functions is net present value. And we are going to check a number of things. That how do you determine that a project is worth investing in? See, like in this question from the pilot paper, the question you are asked here, that after computing the first scenario, we are given 2 more scenarios. And in these scenarios, you are supposed to determine that the project or the investment that you are doing here will actually, how will this project be in the 3 scenarios? probably which scenario will be best for an investor. So that outcome will help us actually to determine after running the two scenarios. So in capital budgeting, decision making remains in understanding whether the project and investment area are worth the funding of cash. And we are going to use several ways of deciding this. Capital budgeting decisions, we are going to use a number of things. One is the payback period, the discounted payback period, the net present value, the internal rate of return, and the profitability index. Those are actually things that will help us to determine whether a project is worth investing in. So today, we are not going to check the payback period or the discounted payback. We are going to check first on the net present value. So that is what I want us to check and actually confirm whether it will help us to get this net present value. So we are going to use the data here, and we have this data. I'm going to open data. I'm going to share the data with you there, and then we get this computed together. Here we have the data. Here is our data. I still believe that you still remember the functions of getting the net present value. If you remember very well, the net present value is computed as the present value of cash inflow, this cash outflow. Then we need to actually compute. So the present value is already given. I have a simple formula that indicates how this function works. That when you are working with this function, the net present value, then a simple formula, so we are going to use your own formula. The net present value only works when you are given a series of cash flow that is inflow and outflow. If you are not given that, then you don't have other ways but to use the formula. You must use the formula. You don't have other ways. And when the net present value, we say that the net present value is the difference between the present value of future cash inflow and the present value of cash outflow over a period of time. I know you remember this. The net present value is widely used in capital budgeting to help us know the profitability of the project. How do you decide that the project is worth? If the net present value is positive, then the project should be accepted. It indicates that the earning of the project is more than the amount invested in the project. So the project should be accepted. So if the net present value is negative, then this one indicates that the project in which you invested your money does not provide a positive return. So the project should be rejected. So how do you achieve this? When you're using Excel, like in this example here, net present value is actually an Excel function. That is, if you search for it, you'll get it. Net present value. You can even write it somewhere in your book that the net present value returns the net present value of an investment based on a discount rate and a series. That one you have to highlight, that a series of future payments, some that will be payment. If it is payment, it will be negative, and incomes, which will be positive values. If you are not given a series of these payments, then this function will not work. You will not use it. Here, you don't have otherwise, but to use the net present value formula. And you insert this net present value formula. So here, the net present value formula, this is my formula. I know you have your formula and you have been using it. I've simplified this formula in this manner. That is, we have the cash flows divided by 1 minus I to the power of t minus the initial investment. For now, we are going to use this formula here. It give us the same answer. And here, the I stands for the required rate of return, and T stands for the time, that is the number of periods. So if you are to insert that formula here, then how will be the formula? Let's check. This is my data. I'm going to separate this screen to 2 so that we can insert our formula referring to the formula here. When you are given the formula, or when you are working the formula and the data is given, then you use the cell references. That in this case, you start with an equal sign. You select the cash flow, which is this cell here, divide by what? Divide by, in bracket, we have 1 minus I. I here stands for the internal rate, the rate of return, the required rate of return, which is given here in cell B5. Then you close the bracket. Then to the power of t. Now, where is the power? On the keyboard. And someone tells us where is the power in the keyboard. You can type there. Type that symbol. Yes. Not, is it Control Shift? Not number 6. If you type number 6 only, that is not power. So the power is actually designated by the symbol. That symbol designates the power. So you're supposed to shift number 6. So you hold shift and then you press number 6. That means to the power of t. And the t is already provided here. Then from there, we reduce the initial investment. So once you do that, then you are going to compute that net present value. Net present value. So you see how you have computed that? I know you don't have the data. Let me share that data. Then you can work out yourself. If you are very fast in typing, then that is something you have already done so far. Just have it. But I know so I've sent this. So you can download it from there. I'm sending another copy in WhatsApp. So those who are praying, just go and pray very fast, then come back. Then once you get that file, you download it. Then the first worksheet is where we have that, data. Also download it in WhatsApp. You get that worksheet, then you work on it. So you can actually check the formula. Here we have included the cells. So the cell B3 divided by other cells 1 minus So let's proceed. That is the first part of this function. That is the net present value. Our net present value, of course, is positive number. That means this project was actually worth investing in. So our next discussion, we are going to check. So this one you come to discuss later about those functions used, the way of checking the net present value. Here we have it. So, and we have computed. So you are told this was the question solving that problem, that a company A Limited wanted to know their net present value, cash flow, if they invest 100,000 today, and their initial investment of the project was this amount, that is initial investment, for 3 years of time, they are expecting the rate of return to be 10% yearly. Then from the above available information, you're supposed to calculate the NPV. So that was the question. And the solution we have already given. The solution you have given, that is, we have inserted the function there, the net present value, and so on. So that is how you solve out these solutions. Then, I think that one is clear. So our next discussion, we are going to check on when another question like this one is given. So here tunaambiwa that the net present value accumulated these amounts. After we run this 1,000, 1 minus 10 to the power of 3, that is our initial investment, we get that amount. Then The NPV was positive, so we accepted the project. We accepted the project. How is the formula? We said that the formula is right here. So our next discussion, the question was a bit different because you are told that in the second example, you are given a weighted average cost of capital for calculating the net present value. Because in the weighted average cost of capital, we consider that the weight of equity and the debt, also the cost of equity and the debt. So we are supposed to calculate the NPV. Now here you can use the Excel function. So the company X, Y, Z Limited provides the following details regarding their project for 10 years. We are given the free cash flow of the firm, the free cash flow of the firm given over a period of 10 years. That is, we have the cash outflow and the cash inflow. That is a series of payments. And again, we are given the discount of 15%. So if you are to compute the net present value of this, then here we can use the Excel function. Why? Because now, when computing this, the net present value in Excel will work when you are given that series of payments. So let's see how this function will work. We're looking for what? The net present value. Sorry. Sub up to net present value function. Yes, I'll open that, and this is how. So is it this one, surely? Just a minute. Let me check. Again, I get it. It's supposed to be on the same worksheet. We need to reduce some of this worksheets here. Let's reduce this one. That is our data. That is our data. I think the data I sent you, I don't think it's that one. You will get the data I've sent you. We are going to use it for the next computation. So that is, it was in sheet 1, we have computed that. In sheet 2 and sheet 3, we're going again to run more functions there. So we're going to use the same data. But now this is a different data set. This one you have to type because I don't have it in the zooming machine. You just type this. So we are given the free cash flow to the firm. Where we have these negatives, it means what? It means that the amount was given in. And remember that usually negative can be indicated with a negative symbol or sometimes in brackets. In most cases, it will be provided in brackets. So if it's not actually showing in brackets, it means that there's a setting somewhere that is supposed to show that the workbook, that the amount in negative should be in brackets. So it's supposed to be under advanced tools. come to check that. It's supposed to be activated somewhere. So just type the data. Type the data very first. So in this case, now you can compute the net present value using the net present value formula. Because we said that this function NPV will return the present value of an investment based on a discount rate and a series of future payments and incomes, as we have given here. So you have been given the future payments, 2 of them, and a series of income. Then the discount, then the net present value will work here. Because then you select the rate, put a comma, you select the series of payments, and then you close the bracket, and this one will give you the net present value for that investment. So you get that? So we have said that you insert the function, you click on insert function, then you select net present value. Click OK. You select the rate is 15%, then the future cash flow, then you click OK again. So it will give you the net present value of these amount. So that is working with the net present value. Then, if you are given a series of payments, a series of cash flows, these are 10 years. That is 10 cents. Some with inflows, others with outflows. Then that is the only place where the net present value works. That is the net present value formula works. Otherwise, if you are not given the series of payment, then you must use the net present value formula. So you finish typing. So I can see someone saying about the formula. Remember that the formula I've used there, I have included the initial payment. I say there is a formula that you use in class. So you need to confirm whether in that formula, are you given all the parameters available in that question? Are you given all the parameters? If you are given all the parameters, then you apply them in your formula. You can use your own formula. I know this formula, you come to use it somewhere. That is what we say, cash flow 1 plus R. We will come to use that formula somewhere. So I wanted to show you first, how do you apply this formula? You have to use the cell reference to work with the formula. That is, when you're working with the formula, you must use cell references. You must select where are these cells. You include the cell references. So that is to achieve the answer. So the volume is too low. I think your microphone is too down. So just adjust your volume. You will get it. So the next discussion, again, we have seen how you compute this net present value if you are given a series of payments, And in most cases, the series of payments will be provided sometimes by the examiner. So here, you just need to insert the function and compute that series of payments. So in that worksheet I send you, now I want to confirm a little bit further that when you are using the PMT to confirm whether the project is won or the project is not won. Whether the project is worth or the project is not worth. That is our next discussion. We are going to check the net present value to confirm whether the net present value, whether the project is worth or not. So this one I'm going to share, probably let me share that worksheet. Then you have the worksheet I send you. That worksheet I send you, you can click on sheet 2. It will come to perform it there in sheet 2. Then in sheet 3 again, and again in sheet 4. In sheet 4, you'll be working on internal rate of return. So, able the worksheet I send you, that is where we have computed this net present value. You click sheet 2, you'll get that. We have 2 projects. The net present value was already computed. You can delete it. We will compute it again. Project X and project Y. Those 2 projects we are given there. Then with that worksheet, there is still another worksheet that is now in that booklet about understanding the net present value. The correct net present value formula in Excel is NPV function to calculate the present value of a series of future cash flow and subtract the initial investment. That is a series of future cash flow and subtract the initial investment. And subtract the initial investment. So as you confirm this, then I will share that worksheet. Let me share the worksheet with you. Present value function. I have realized that the worksheet is just the same with what I've given you. I've just realized that the worksheet is just the same. If you check the worksheet I've given you, then you realize that in sheet 2, we have this and this. And in that worksheet, I have it in sheet 1. You're supposed to compute the net present value. So you don't have to send again this, you just use the first function there. First function there. So just download that worksheet. I've sent that worksheet there. Just download the worksheet so that at least it will read the same as the one you are using there in the booklet. So you'll have that worksheet. Again, I'll send it in WhatsApp. So if you don't have, you can get it from either platform. Yeah, and now let's work out on this. Let's work out on this. WhatsApp is a bit slowing down. So let me just give it time to load WhatsApp too. So from this discussion, we are told, David, that Project X requires an initial investment of $100. It is provided in a specific sense. We expect a profit of 0 at the end of the first period. That is, it will return 0. A profit of 50 at the end of the second period, and a profit of 150 at the end of the third period. So meaning that this is our cash flow. And this is the formulated data. That is the data that I have sent you already. So that worksheet shows the project A. We are given the rate. This was the initial investment. And here we are given what? It returns 0, it returns 50, it returns 150. You are supposed to compute the net present value here. What did we say above here? We said that the correct NPV formula in Excel uses NPV function to calculate the net present value of series of future value, cash flow. And then we subtract the initial investment. we subtract the initial investment. That is exactly what we are going to do there. We'll insert the function. Then after that function, we are going to subtract the initial investment. So our formula will be like this. We insert the net present value. Sorry. So we insert the function NPV. Then the rate is given here. Then the series of payments. That is the first payment for 0, 50 and 150. Then, so if you select this value 1, it is actually indicating here that the rate of, that is the rate you have provided the rate already. Then you select the series, the value. Here, the values, value 1 and value 2 are 1 up to 254 payment and incomes, especially spaced in time and occurring at the end of each period. That is what it means. So once you do this, you're supposed to subtract the initial investment. And since it was minus, we will not type minus, because you type minus, it will be minus, minus, plus. So you put plus this amount here. And by doing so, it will compute our net present value. So I hope you have seen that. It computes the net present value for the first project X. Let's go to project Y. So we have seen how that one has computed. That explanation that this rate of return is best alternative of the project. That is, for example, you could also put your money on high yield saving account at the interest of 15%. That is what this rate of return is all about. The discount rate equals to 15%. Then as we proceed, we will get here that explanation of this, a positive net present value indicates that the project rate of return exceeds the discount rate. In other words, it is better to invest your money in project X than to put your money on other high yield saving accounts at the interest of 15%. So that is about the first project. Project X. Project X has actually indicated the net present value of 36.43. Let's see another project Y. We want to calculate for the project Y. The rate of the discount rate is the same. The amount invested is the same, $100. But now the payback time. This project is paying the amount, or is paying earlier than the previous project with the same amount. If you use now the previous worksheet I send you, the NPV, not NPV function, the NPV, I have compared the two projects in the same worksheet. And the first project, we have already done this. We said that we insert the function NPV. You can even type it direct. You say NPV, then you select NPV function. The rate is 15%, comma. The series of payment is this series of payment here. You close the bracket. Then you minus the initial investment, which initial investment here is minus. You just select plus, and it will give you the NPV of this. For the second project, we are going to insert the same and insert the function NPV, or you can type it direct, say is equal to NPV. Double click the function down here. Then you select the rate of this is the rate. Then you put a comma. Then the series of the cash flow is here. You close the bracket. Then we subtract the initial investment. What do you notice? After embedding the two formulas in our worksheet, you will realize that the net present value of the first project X is lower than the net present value of the second project Y. So it is lower than that. So please, technician, come and change this battery. So if the net present value of project, remember that the two projects are returning the same amount. That is $200. But the first project is returning it a bit late than the second project. That way the net present values are different. The two net present values are different. Then we can simply say it is worth investing in project Y than investing in project X. Why the difference between the two net present values is what we said about the time value of money. Time value of money. That the first project or the second project Y will pay much earlier than the second project. Okay, so that net present value. The explanation of the project here, the net present value of project Y is higher than the net present value of project X. Therefore, project Y is better investing. Understanding the net present value function, that NPV function simply calculates the present value of a series This is always a very easy task to help you do that function very, very fast. Hope we have seen this. Now, in that worksheet I've sent you, the net present value function, you will see the two projects, and we have computed the value of two projects. But after this, we have another project in project A. And the project A have given us the net present value of 0. So when do we get a net present value of 0? So that is another thing that we're going to see here. Remember that today we're just checking on the art shell on these functions. Then later you'll come to do some applications, especially now in capital budgeting, when you want to identify the projects using the payback, the discount rate, net present value, the internal rate of return. We're going to discuss now this one. So this project A requires an initial investment of $100. We expect a profit of 0 at the end of the first period, and a profit of 0 at the end of the second period, and a profit of 152.09 at the end of the third period. And that is what we have done. So we go back to that worksheet. This is our worksheet. Then you want to insert the function. How do you insert the function? We say equals to NPV. We select NPV here. Then we choose the series of payment. How those pay? Oh, sorry. We start with the rate. Don't forget that. You follow this small syntax down here. So we start with the rate, which is 15%. Then, comma, we select the series of payment, close the bracket, and then we minus the initial investment. Notice that we get 0. What does it want? Does this one implicate? That a net present value of 0 indicates that the project generates a rate of return equal to the discount rate. That is, the project generates the rate of return that is equal to the discount rate. In other words, that both options, investing your money in project A and putting the money in another saving account at the same interest, are equal. That's simply what it means. That we check this, assume that this project, if it was a bank account, how much will investment worth in 3 years at the annual rate of 15%? Then it is that 152. So that is working with the net present value when it becomes 0. Then later, as we discuss the internal rate of return, you'll notice that the internal rate of return of project A will be equal to 15. We can even check whether that one is true. Though we have not yet discussed the net present value. That is the internal rate of return. Internal rate of return. So when you're given the internal rate of return, you're supposed to compute now this here. And you insert the function. This one is not complicated. You just type IRR, the internal rate of return. It returns the internal rate of return for a series of cash flow. Now here you select the cash flow. That is starting from this downwards. Then you close. We don't have to set the rate here. Remember that we are looking for that rate. We are looking for that rate. And you realize that the rate is 15%. When the internal rate of return is equal to the discount rate, the net present value is 0. The net present value will give you a 0. So I hope you have seen that the internal rate of return of project this will be equal to 15. That way we got 0. We have said that when do we get 0? When the net present value equals to 0, it indicates that the project generates a rate of return. A rate of return. The project generates a rate of return equals to the discount rate, which sometimes if you are given or you invest your money and the rate of return is the same with the discount rate, then there is no difference doing this same way the bank do the investment. So that is how you proceed with that. So our next discussion, we are going to check on the internal rate of return. Internal rate of return. And what is this? And where do we use it? So previously, we've talked of the net present value, and we have said, what is net present value? The difference between the present value of future cash inflow and the present value of cash outflow. So again, we are going to check on this. The internal rate of return is specifically what? Then we can say that the internal rate of return is used to calculate the internal profit for some investment in financials. The internal rate of return is actually an inbuilt function in Excel used to calculate the same. It is a financial formula. This function takes a range of values as input, for which you need to calculate the internal rate of return, and a guess value as the second input. That is, you'll be having a guess value as the second input. So the guess value is not mandatory, it's optional. But sometimes you can use it. If you are really guessing, or you can actually guess what is actually the internal rate of return of a specific investment. So here we are given an example that suppose your company made an initial investment of $50,000 and expect to generate $10,000 every year for the next 10 years. We can use this data to calculate the internal rate of return, which is the rate of return you get for your investment of this amount. So as a result, the internal rate of return comes out as 15%. It is equal to the money invested at 15% for 10 years. Therefore, the internal rate of, we are going to run that. The internal rate of return, we say it is an built-in function in Excel, which you are going to insert. And we are going to use it to compute these functions. So we are going to use a simple data, and probably I'm going to insert this to send this data to you. And then we get this data. You can have the data. I think you have this data. So you don't have to type this down. You just need to do what? Just need to download this data in your worksheet. So I'm sending that worksheet there. Download the worksheet. Then in sheet 1, that is where we have that work, that data. I have sent the 2 copies, one in WhatsApp and the other one in the Zoom platform. So now, with that worksheet, we are to compute the internal. This is income generated. This is amount invested. First year. Second year, we got this amount. Third year, we got this amount. Fourth year, we got this amount. The fifth, we get this. Suppose you are asked to give the internal rate of return for the 2 consecutive, that is, you're supposed to give the internal rate of return for the 3rd year and for the 5th year. You're supposed to insert that formula that will give you the internal rate of return after 3rd year and after the 5th year. So we are going to compute that, the internal rate of return after the 3rd year. So we type here after the 3rd year, we do it here. So how do you compute that formula? Again, we insert the function. You type there equals to internal rate of return, select the function, then set the values. Is somewhere we are told about this, that the formula will have 2 arguments. The formula used to calculate this has 2 arguments. The first argument is the range. That is, this is the required parameter. What do you mean by required parameter? That it have to be there. A range of cells denotes the series of the cash flow for which you would calculate the internal rate of return. The second argument is the guess, and this is an optional parameter. That means if you are not actually guessing the value, then you don't have to put it. So it denotes that the number you guess is close to the result of the internal rate of return. If no value is mentioned, then it takes the default value of 0.1, that is 10%. Then finally, we have this parameter that denotes optional parameters. So the function returns the numeric value that could be positive or negative. So you follow that the first value, we're supposed to select the value. And since we are looking for up to, after the 3rd year, we select the values from here up to here. Then we close the bracket. The internal rate of return can be a positive number or a negative number. Notice that the first internal rate of return has given us a negative value. Who can really explain why the internal rate of return is negative? Why is internal rate of return negative? Agnes? Why is internal rate of return negative? Someone say that it is lower than the rate. Who else? It is lower than the required rate of return. So if you check at this investment, you will find that this particular investor invested 10,000. That is the amount he invested. The second year, it returned 2,000. So that means bado ajapata, it has not returned back his money. The investment has not yet returned the money back. And even the third payment, because the two of these will equal to 7,000, it has not yet returned the amount invested. That means that the internal rate of return will be a negative value, that the investor has not yet returned the amount invested. That is the explanation of this. That by investing this amount, then the calculation of this have not yet returned the amount invested. And because of this reason, then the internal rate of return is positive, is negative. But by the time it is reaching year 5, according to our projection, then you will notice that the internal rate of return will be a positive number. Because by then, up to here, it has already returned the amount, year 4. And up to year 5, it has returned the amount and exceeded. So that means it will give us an internal rate of return, a positive value. So if we are to generate the internal rate of return for the 5th year, internal rate of return after the 5th year, then we should get a positive number. You can try that. The internal rate of return after the 5th year. So what do we get here? We insert the internal rate of return formula, we select internal rate of return, then the series of payment from here up to here, and you'll find that it will give us a positive number, that our internal rate of return is positive. That indicates that our investment is actually has actually returned back what we invested. It has returned back what we invested and exceeded. So that is how these functions, the internal rate of return works. So I think that one is clear. So in our next discussion, we'll check first what we left about compounded interest. And again, we'll proceed with this internal rate of returns and the net present value. We'll discuss in details about the capital budgeting. And in that book, find that understanding the internal rate of return in Excel, calculate the project internal rate of return. The internal rate of return is the discount rate that makes the net present value equals to 0. So we have seen an investment, this amount, that after computing this one, it will generate an internal rate of return of a specific amount. So you have seen that you can repeat that again, that the internal rate of return is the discount rate that makes the net present value equals to 0, I hope that is something you can understand what it means. So in our next lesson, we are going to check more details on that. About those who are asking the notes, you want to compile the notes as per the syllabus, and that is arranging them in that particular order, that at least you'll be able to flow with the notes. So, but the financial function already sent this copy, and I think you're still going through that copy as you practice those functions. Once you do them, you can go back and again practice again, so that at least you'll be able to understand this. Then later you're going to do the application part of it that will help you to master this content. So today, I'm going to wind there. unless you have a question, you can claim your question there. I'm going to read the question and then later shall come up with the solution. So up to that level, see you on Saturday. Have a great time.